Hey there, this is Carly Hollis, and this is my final project for the genetics class. I moved my personal screen up to the upper right-hand corner just because I have some pictures to display throughout this presentation. I don't want that to interfere with it. Anyways, I will be presenting critical congenital heart disease, also abbreviated as CCHD, which I will probably refer to it as. Anyways. So I'm just going to start by explaining what CCHD is, and it means that there's just a defect or an issue with the heart at birth. Since it is congenital, that means that it's present at birth. So these issues that can be present can consist of heart structure abnormalities, heart valve abnormalities, and arteries and veins near the heart can also be normal. That is also kind of umbrellaed into this topic here. So these heart defects typically lead to low oxygen saturations. You'll see that each of these heart defects have a lot of things in common with each other as far as signs and symptoms and stuff. And just a fun fact, about 7,200 babies are born each year with CCHD. As a pediatric respiratory therapist at the University of Virginia, I see a lot of these heart defects, so to me it seems a lot more prevalent than just 7,200 babies. But anyways, that is why I chose this project. It's something that near and dear to my heart. I go to work and deal with one of these every single shift, at least. Anyways, so I will begin describing some of the heart defects that there are. So some examples of CCHD, I went ahead and did the ones that I see the most of just because I know the most about them. Anyways, there are a variety of different defects that fall under CCHD. So let's start with hypoplastic left heart syndrome, coarctation of the aorta, double outlet right ventricle, or sometimes called Dwarfs, Ebstein's anomaly, tetralogy of flow, transposition of the great arteries. So I'll be doing slides over most of these and kind of giving pictures of what a normal heart would look like and what an abnormal heart would look like. So hypoplastic left heart syndrome, or HLHS, this is probably the one that I see the most of. So it just refers to the left-sided structures of the heart are extremely underdeveloped. These structures can include mitral valve, the left ventricle, the aortic valve, and the aorta. This occurs during the first 8 weeks of pregnancy, and some signs and symptoms of hypoplastic left hearts are shortness of breath, cold extremities, and this is because they have poor perfusion, and they kind of have this mottled look to them. And another is poor feeding / sucking and a rapid heart rate, which you could expect because the heart is having to do a lot more work with a lot less. So here I have the normal structure, which is on the left, and the hypoplastic heart, which is on the right. And you can see when you look at these left ventricles how much smaller this left ventricle is compared to your normal left ventricle, and it even goes as far as to show you a small mitral valve. Also a small ascending portion of the aorta and a small aortic valve. So it's just, they're all small. They don't do as much work as they would if they were normal. Next is coarctation of the aorta. This refers to just the narrowing of the aorta, so you have an increased resistance that your heart is having to pump against. So it can occur along any part of the aorta, except it is most commonly seen near the ductus arteriosus. And this narrowing, like I said before, forces your heart to pump harder and faster. So again, some signs and symptoms, which a lot of them have a lot in common, is paleness, irritability, difficulty feeding, and a harder time breathing. And you can see here where this little line cuts into this right here where it narrows out. That is the coarctation. So, transposition of the great arteries, or transposition of the great vessels, if you've ever heard of it in either of those forms, it refers to the same exact thing. So it's a defect in which the aorta and the pulmonary artery are switched. So for those who aren't familiar with heart anatomy, the aorta is typically connected to the left side of your heart, the left ventricle, and it pumps to your system, your body, your systemic blood flow is what it provides. And just as it sounds, pulmonary pumps to your lungs from the right side of your heart, And in this case, those two are switched. So oxygen-poor blood bypasses the lungs and continues to circulate through the body since the aorta is connected to the right side of the heart. And oxygen-rich blood is continually pumped between the heart and the lungs since the pulmonary artery is connected to the left side of the heart. So again, some signs and symptoms include breathing issues, blue skin, and poor feeding. So in these heart descriptions, any part of the heart that is blue is where unoxygenated blood is going to be, and any part that is red is going to be where oxygenated blood is going to be. So you can see in this normal heart, the pulmonary artery is always carrying deoxygenated blood. Fun fact, pulmonary artery is the only artery in the system that carries deoxygenated blood. And the aorta is pumping from the left side of the heart out to your body. And in this picture with the transposition, you can see that the aorta is blue, so it is carrying deoxygenated blood, and that is going out to your body. And this pulmonary artery is red, so it is carrying oxygenated blood back to your lungs to continue to be oxygenated and just do this vicious circle. Next is going to be double outlet right ventricle, which is Dwarf's, abbreviated sometimes like that. So in this case, the pulmonary artery and the aorta are both connected to the right ventricle of the heart. Ding, 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 huge issue. So oxygen-poor blood just continues to circulate your body. So children with Dwarf have also been seen to have other heart anomalies or abnormalities, and these can include pulmonary valve stenosis, pulmonary atresia, mitral valve abnormalities. And again, signs and symptoms include a rapid respiratory rate, a heart murmur, and poor weight gain. So you can see here this normal heart, these two are separated in connecting to different chambers of your heart, and here the right ventricle is providing it all. However, you also have a huge ventricular septal defect, so you will get mixed blood or mixing of your oxygenated blood with your deoxygenated blood. And this ventricular septal defect does not differentiate. So essentially your heart just has one huge ventricle instead of a right ventricle and left ventricle. Next is Tetralogy of Fallot, which is made up of 4 defects, which is ventricular septal defect, pulmonary stenosis, aortic valve enlargement, and ventricular hypertrophy, which just means you have when you hypertrophy your muscles, they are bigger. Anyways, this can cause a reduction in the amount of oxygen that is sent to the body. Typically, this is diagnosed after birth. Some signs and symptoms are tet spells, which is suddenly you're feeding your baby and they turn blue, and it's just that is referring to a tet spell, is that they are becoming increasingly cyanotic with either crying or feeding or anything, that a temper tantrum, like whatever it may be. Seizures and developmental delay. So you can see in this normal heart, all of these are connected correctly, but you have, let's see. Oh, there it is. Okay, so here you can see this is a defect right here, and your aorta should not have mixed blood. Your aorta should primarily have oxygenated blood, so you can see how it's kind of purple, and they're trying to signify that this is mixed blood, and you can see the septal defect in between the ventricles. So some molecular causes of CCHD, just given that there are so many different diseases that fall under what CCHD is, there is not one molecular cause that you can just pinpoint. However, for all of my projects, I did identify a gene, which is the CFC1 or crypto-FRL, cryptic family 1, and this is responsible for causing heterotaxy. This affects organ development, organization, left to right axis development in CCHD, and this is a loss of function mutation. The mode of inheritance for a lot of CCHD cases, it is just sporadic mutation that occurs. However, when it is inherited, it is an autosomal recessive disease. Here is a simple pedigree that I made. So anybody who has these little green squares has CCHD, and those who have the little blue inside of them are just carriers. So given that Kelly and Elena is normal and Kelly is a carrier, they can only have a daughter that is a carrier, and so on and so forth. So genetic testing options, there are 37 different options. 3 different ones are congenital heart defects panel, CFC1 completing sequence, prenatal known familial mutation. There's some descriptions of each of those there, and it ranges between $900 and $5,000. And those are my references. And that is all I have. Thank you.